In today's video, we're exploring the most advanced humanoid robot ever designed for home use, a machine that's about to fundamentally change how we live, work, and interact with technology in our daily lives. But here's the catch. While most people are still arguing about whether AI chatbots might take their jobs someday, this Norwegian-built robot is already moving into real homes this year. And the most surprising part? It's learning to understand human behavior not in sterile labs, but by living alongside actual families. Will your home be next? Welcome tech enthusiasts and curious minds. Today, we're exploring a groundbreaking technological advancement that's not just fascinating but potentially life-changing: Neo Gamma, the humanoid robot that's stepping out of science fiction and into reality. A Norwegian startup has quietly built a robot that might fundamentally change how we live. For decades, we've been promised humanoid robots that would live alongside us, from Rosie the robot in the Jetsons to Baymax in Big Hero 6. But these always seemed like distant dreams, something our grandchildren might experience. That timeline has been dramatically accelerated. A company called 1X, with roots in Norway and Silicon Valley, is already testing their Neo Gamma humanoid robots in real homes, with plans to expand to hundreds or even thousands of households by the end of 2025. This isn't some glorified vacuum cleaner or stationary smart assistant. We're talking about a full-sized talking humanoid designed to become part of your family. The robot can navigate your living space, handle delicate objects, perform household chores, and engage in natural conversations, all while learning and adapting to your specific home environment. So why is this such a revolutionary development? And how did we get here so quickly? Let's dive into the remarkable story of Neo Gamma, explore its groundbreaking TED Talk appearance, and examine how this technology could reshape our relationship with machines forever. The origins of Neo Gamma. The visionary behind the robot. The story begins back in 2014, not with a massive corporation, but with a visionary Norwegian engineer named Bernt Øyvind Børnich. He initially founded Halodi Robotics with a revolutionary idea: creating general-purpose robots that could safely coexist with humans and genuinely improve our lives. Børnich wasn't just another tech entrepreneur jumping on the robotics bandwagon. With a background in mechanical engineering and a passion for creating machines that could work harmoniously with humans, he approached the problem differently from the start. While most robotics companies were focusing on specialized machines for industrial applications, Børnich envisioned versatile robots that could adapt to the complexity of human environments. He understood that building a humanoid robot wasn't just about combining motors and computers. The fundamental technology needed to be reimagined from the ground up to create machines that could operate safely in human environments. This required rethinking everything from power systems to mechanical joints to sensory processing, essentially creating a robot architecture that mirrored human capabilities while prioritizing safety above all else. Early technological breakthroughs. In 2018, the company had its first major breakthrough. They developed the Revo 1, a servo motor with an extraordinary torque-to-weight ratio that revolutionized robot movement capabilities. This technical advancement was crucial because traditional robots use high gear ratios to generate power, making them strong but rigid and potentially dangerous around humans. The Revo 1 allowed for flexible mechanics that could respond naturally to their environment, much like human muscles and tendons. The significance of this innovation cannot be overstated. Most industrial robots operate with rigid precision but lack the ability to sense and respond to unexpected forces, like a human bumping into them. The Revo 1 introduced a form of mechanical compliance that made physical interactions between humans and robots vastly safer. If the robot encountered unexpected resistance, it would yield rather than power through, dramatically reducing the risk of injury. This breakthrough led to further innovations in what roboticists call series elastic actuation, essentially, the robot equivalent of tendons and muscles that can absorb shock and respond dynamically to environmental forces, much like a human body does naturally. By 2020, the company had refined these systems enough to begin building complete robotic limbs with human-like movement capabilities. The first commercial product, Eve. By 2022, they had evolved enough to deploy their first commercial product, Eve, a wheeled humanoid designed for factories. These robots began working in real industrial environments, handling tasks autonomously. Standing approximately 5 feet 6 inches tall with a wheeled base for stability, Eve featured 2 dexterous arms capable of manipulating objects with impressive precision. Eve was designed primarily for environments like warehouses and manufacturing facilities, where it could assist with tasks ranging from fetching items to simple assembly work. The robot quickly gained attention for its unique combination of strength, precision, and safety, able to work alongside human workers without the need for safety cages or designated robot-only zones that are typical in industrial robotics. But Børnich and his team realized something important as they observed Eve in these controlled settings. Factory environments were too controlled and predictable. The truly challenging and valuable environments for robots weren't in organized factories, they were in the chaotic, unpredictable spaces where humans actually live. To create truly intelligent machines, robots needed to experience the messy, unpredictable world that humans inhabit every day. The philosophical shift. That realization led to a pivotal moment. In 2023, the company rebranded as 1X Technologies and shifted focus to the home environment. This wasn't just a marketing move, it represented a fundamental philosophical shift in how robotics should evolve. Unlike traditional industrial robots with rigid, potentially dangerous mechanical movements, the new generation of robots would incorporate a soft, human-inspired design that prioritized safety for human interaction. This compliant and flexible approach addressed one of the key challenges in bringing robots into domestic settings, ensuring they could operate safely alongside humans without posing risks. The company's leadership articulated a bold new vision. Robots needed to learn by being immersed in human environments, not just by being programmed in laboratories. This approach was inspired in part by how human children learn, not through formal instruction but through exploration, trial and error, and social interaction in real-world settings. This philosophical pivot aligned with recent advances in artificial intelligence, particularly in machine learning approaches that enable systems to improve through experience rather than explicit programming. By combining their mechanical innovations with these new AI paradigms, 1X positioned themselves at the cutting edge of a new approach to robotics. Neo Gamma, Design and Capabilities. Standing at human height with 2 legs, 2 arms, and an expressive face, Neo Gamma represents a significant leap forward from previous prototypes. The most striking aspect is its sleek, minimalist design. Unlike the industrial, mechanical look of most robots, Neo Gamma features a soft, knitted nylon bodysuit. This isn't just for aesthetics, it's a safety feature that reduces potential injuries from accidental robot-to-human contact. The robot stands approximately 175 centimeters, 5 feet 9 inches, tall and weighs around 70 kilograms, 154 pounds, making it comparable to an average human in size and mass. This anthropomorphic design is deliberate. Neo is meant to navigate spaces designed for humans without requiring modifications to the environment. Its proportions allow it to reach doorknobs, operate standard appliances, and access shelves and cabinets in typical homes. One of the most remarkable features is what 1X calls emotive ear rings, illuminated rings on the sides of Neo's head that help communicate its state and intentions. These rings change color and pattern to indicate the robot's operational status, attention focus, and even basic emotional states. This subtle design touch helps bridge the communication gap between human and machine, providing intuitive cues about the robot's state without requiring users to check screens or interfaces. The face of Neo Gamma is deliberately minimalist, a sleek panel with subtle digital eyes that can express basic emotions through shape changes. This design choice balances the need for emotional connection without falling into the uncanny valley effect that makes highly realistic robotic faces seem disturbing to many people. The result is a robot that feels approachable and machine-like simultaneously, avoiding the discomfort that can come with robots that try too hard to look human. Movement and manipulation capabilities. The robot's movement capabilities are extraordinary. Neo Gamma can walk with a natural human gait, complete with arm swings for balance. It can squat down to pick things up from the floor and even sit in chairs. While that might sound basic to us humans, achieving these movements in a bipedal robot represents an extraordinary engineering achievement. Neo's locomotion system builds on decades of research in bipedal robotics, incorporating both traditional control systems and newer machine learning approaches. The robot maintains balance through a complex interplay of sensors, including accelerometers, gyroscopes, and pressure sensors in its feet, that continuously feed data to algorithms that adjust joint positions dozens of times per second. When walking, Neo can achieve speeds of up to 5 km per hour, 3.1 miles per hour, on flat surfaces, though it moves more cautiously in unfamiliar environments. For manipulation, 1X has trained visual models that allow Neo to pick up a wide variety of objects in different scenarios, even in environments it hasn't seen during training. This means it can adapt to specific home layouts and the objects within them, demonstrating impressive dexterity for a humanoid robot. Neo's hands feature 5 fingers with multiple joints, allowing for both power grasps, like holding a handle, and precision grasps, like picking up a pencil. Each fingertip contains tactile sensors that provide feedback about contact forces, enabling the robot to manipulate delicate objects without damaging them. This sensory feedback loop is critical for tasks like watering plants or handling glassware, where excessive force could cause problems. The robot's arm design incorporates the company's proprietary series elastic actuators, giving each arm a payload capacity of approximately 5 kilograms, 11 pounds, while maintaining the compliance necessary for safe human interaction. This means Neo can lift grocery bags or laundry baskets while still yielding if it encounters unexpected resistance. Sensory systems and perception. Neo Gamma's sensory systems are designed to give it a comprehensive understanding of its environment. Multiple camera systems provide visual input, wide-angle cameras for general navigation and higher-resolution cameras for manipulation tasks. These are complemented by depth sensors that create 3-dimensional maps of the surrounding space, allowing Neo to understand the geometry of rooms and objects. Microphone arrays positioned around the robot's head enable directional hearing, helping Neo identify the source of sounds and focus on specific speakers in multi-person conversations. This audio processing capacity, combined with advanced speech recognition algorithms, allows the robot to understand spoken commands even in noisy environments. Additional sensors monitor temperature, power consumption, joint positions, and forces throughout the robot's body. This comprehensive sensory array gives Neo Gamma situational awareness comparable to human perception in many domains, though still lacking in certain nuanced interpretations that humans perform effortlessly. AI and learning approach. Perhaps most importantly, Neo Gamma features an in-house language model that enables natural conversation and appropriate body language. This isn't just about responding to commands, it's about creating a companion that feels natural to interact with. The AI system running Neo comprises multiple specialized models working in concert. A large language model handles conversation and reasoning, while dedicated computer vision models interpret visual scenes. Motion planning algorithms translate high-level commands like pick up that cup into precise joint movements, considering obstacles and optimal paths. These components are integrated through what 1X calls their cognitive architecture, a framework that coordinates perception, decision-making, and action. What sets Neo apart from many other robots is its learning approach. Rather than being trained exclusively in controlled factory settings, Neo learns directly in home environments, which Børnich described as this beautiful chaotic thing that mirrors human nature. This real-world learning environment pushes Neo to develop problem-solving skills and adaptability that would be impossible to cultivate in sterile laboratory conditions. The robot employs several learning methods simultaneously. Imitation learning allows it to observe humans performing tasks and then replicate those actions. Reinforcement learning helps Neo optimize its behaviors based on success or failure. And federated learning enables the robot to benefit from experiences across the entire fleet of Neo robots while maintaining privacy boundaries between households. The human element, teleoperators. Here's where things get really interesting. Neo Gamma isn't fully autonomous yet. To bridge the gap between current capabilities and full autonomy, 1X is using human teleoperators, real people who can view Neo's cameras and sensors in real time and take control of its limbs when needed. This bootstrapping approach allows the robot to learn from human guidance in real-world situations. When Neo encounters a situation it can't handle autonomously, it can seamlessly transition to teleoperation mode. A trained operator at 1X connects to the robot remotely, sees through its cameras, and controls its movements using specialized interfaces. To the people in the home, this transition might be barely noticeable. Neo continues functioning, just with human intelligence temporarily guiding its actions. This approach serves multiple purposes. It provides immediate capability for handling complex situations while the AI is still learning. It also generates valuable training data as the teleoperators demonstrate optimal solutions to challenging tasks. Over time, As the AI observes enough examples of humans solving particular problems, it can learn to handle those situations autonomously. 1X sees teleoperation as a transitional technology, a bridge between today's limited autonomy and tomorrow's fully independent robots. As NEO's AI improves through observation and learning, the frequency of teleoperation interventions should gradually decrease, with the robot handling more situations independently. The groundbreaking TED Talk. Making history on stage. In April 2025, Neo Gamma made history as one of the first humanoid robots to appear in a TED Talk, demonstrating advanced capabilities that signaled a new era in human-robot interaction. The presentation, which took place on April 8, 2025, featured 1X Technologies founder Bernt Børnich showcasing how this home humanoid robot could transform everyday life through its ability to perform household tasks with remarkable dexterity. The TED Talk titled Meet Neo, Your Robot Butler in Training began with Børnich posing a powerful question to the audience: what if doing your chores were as easy as flipping a switch? This provocative opening set the stage for demonstrating how Neo Gamma could revolutionize our approach to household labor. As Neo walked onto the stage alongside Børnich, the audience's reaction was palpable, a mixture of awe and nervous excitement as the robot moved with a natural, human-like gait. The TED Talk venue, with its characteristic red circular carpet, provided a perfect showcase for demonstrating Neo's ability to navigate human spaces designed without robots in mind. The live demonstration. One of the most compelling aspects of the TED Talk was Neo Gamma's live demonstration of its capabilities in front of the audience. The robot showcased several practical skills including vacuuming, watering plants, and providing companionship. These weren't pre-programmed routines but adaptive behaviors responding to the specific environment of the TED stage. The plant watering demonstration particularly impressed viewers, as it required precise control and sensitivity. Neo successfully grasped a watering pot, tilted it carefully, and poured water into a plant's soil with considerable care. This task demonstrated multiple complex capabilities: visual recognition of the watering can and plant, precise grasping, force control to avoid crushing the pot, and fluid manipulation through careful tilting, all skills that had previously been challenging for robots. The vacuum demonstration showcased Neo's mobility and environmental awareness. The robot identified areas needing cleaning, navigated around furniture legs, and adjusted its approach based on different flooring surfaces, transitioning smoothly from carpet to hardwood. Throughout the demonstration, Neo maintained awareness of people's positions, carefully avoiding the space around audience members and Børnich himself. While there were minor hiccups reported during the demonstration, such as when Neo attempted to put back the watering pot, the overall performance was considered impressive. At one point, Neo miscalculated the height of a shelf and bumped the watering can slightly. Rather than continuing with the flawed movement, the robot demonstrated adaptive behavior by readjusting its approach, showcasing its ability to recover from errors, a crucial skill for real-world applications. This public demonstration validated the advanced design of Neo's tendon-driven actuation system, which enables the robot to perform delicate tasks with the necessary care and precision. The audience could observe the natural compliance in Neo's movements, the way its arms yielded when meeting resistance rather than rigidly forcing their way through obstacles. Conversation and interaction. Beyond physical tasks, Neo demonstrated impressive conversational abilities during the TED Talk. The robot engaged in natural dialogue with Børnich, responding to questions and even displaying appropriate humor at several points during the presentation. When Børnich asked how Neo was feeling about being on stage, the robot replied, "A bit nervous. There are more humans watching me today than in my entire operational history combined," eliciting laughter from the audience. Neo's voice, slightly synthetic but warm and gender-neutral, was designed to be pleasant without attempting to perfectly mimic human speech patterns. Its language processing capabilities allowed it to understand context and maintain conversational coherence throughout the presentation, even when Børnich departed from scripted interactions. The robot also demonstrated appropriate body language, turning to face whoever was speaking and using subtle gestures to emphasize points. These nonverbal communication abilities highlighted how far humanoid robots have come in creating natural human-machine interactions that don't feel mechanical or scripted. Articulating the vision. During the presentation, Børnich articulated a powerful vision for the future of robotics, drawing parallels between the historical mastery of energy and the potential mastery of labor through robots. He described a future where the work needed to build the products we use, the services we rely on, and even the chores in our homes will be as effortlessly accessible as energy is today. This vision positioned robots like Neo as solutions to labor shortages and the increased demand for care in aging populations. Just as electricity transformed human society by making energy abundant and accessible, Børnich explained, robots like Neo will transform labor from a scarce resource to an abundant one. He described how this abundance could address critical societal challenges, from elder care shortages to productivity limitations that constrain economic growth. Børnich's presentation style was notable for making complex robotics concepts accessible to a general audience while still conveying the revolutionary potential of the technology. He shared personal anecdotes about Neo being integrated into his own household routines, performing various chores either autonomously or through remote operation. These stories humanize the technology, helping audience members envision how such robots might fit into their own lives. Throughout the talk, Børnich emphasized that Neo wasn't designed to replace human jobs but to handle the mundane tasks that prevent people from focusing on more meaningful work. "We're not building Neo to take jobs, we're building Neo to take chores," he explained, drawing a distinction between economic labor and the routine maintenance tasks that consume personal time. Public reception. The appearance of Neo Gamma at TED 2025 marked what many consider a significant milestone in robotics. As described by observers, this was the first time a humanoid robot interacted with a live audience in such an intimate setting, standing and talking just like a human. The demonstration generated considerable interest on social media platforms, with numerous professionals sharing and commenting on the presentation. LinkedIn posts from technology professionals and industry observers highlighted the impressive dexterity demonstrated by Neo Gamma, particularly during the plant watering segment. Comments frequently compared the demonstration to science fiction becoming reality, with many noting that Neo's capabilities exceeded their expectations of current robotics technology. Several technology publications covered the event extensively, with headlines like "Neo Gamma shows the future of home robotics at TED" and "1X Technologies humanoid robot wows TED audience with household skills." These articles analyzed both the technical achievements represented by Neo and the broader implications for society if such robots became widely available. Observers noted how Neo's human-like movements and natural conversation captivated the audience, with Børnich remarking during the presentation that it's fascinating because Neo is standing like a person and talking like a person but isn't human at all. This observation underscored how robots like Neo are blurring the line between human and machine capabilities, creating new categories of entities that don't fit neatly into our traditional understanding of technology. The TED Talk also sparked questions about Neo's commercial availability and pricing, indicating substantial public interest in potentially acquiring such technology for home use. While 1X Technologies didn't announce specific pricing during the presentation, the level of interest demonstrated significant market demand for advanced home robotics. Collaborations and technological partnerships. The NVIDIA connection. A significant aspect of Neo Gamma's development has been 1X Technologies' collaboration with NVIDIA. This partnership was highlighted during the NVIDIA GTC 2025 event, where a memorable moment occurred when a Neo Gamma robot presented NVIDIA CEO Jensen Huang with a custom-designed black leather jacket featuring a studded NVIDIA logo. This wasn't just a publicity stunt but a demonstration of Neo's capability to handle delicate items with precision. The jacket handover required identifying the correct object, grasping the fabric without damaging it, and presenting it at the appropriate height and orientation for Huang to receive, all tasks requiring sophisticated visual processing and motor control. This collaboration goes beyond publicity stunts, focusing on tackling the many open research challenges in developing AI for humanoid robots. These challenges range from safety and dexterity to visual understanding. The partnership aims to accelerate progress toward autonomous home robots by leveraging NVIDIA's expertise in GPU-accelerated computing and AI. NVIDIA's involvement centers primarily on providing the computational hardware and software frameworks that enable NEO's AI systems to process sensory information and make decisions in real time. Modern AI models require enormous computational resources, especially for applications like computer vision and natural language processing. NVIDIA's specialized hardware accelerates these computations, making it possible for complex AI to run locally on the robot rather than requiring constant cloud connectivity. Teams from 1X and NVIDIA worked closely to train neural networks using data collected from 1X offices and employee homes. This data helped NEO learn to handle everyday tasks such as grasping a cup and placing it in a dishwasher, verifying the robot's compatibility with external research codebases and setting the stage for more complex capabilities. The collaboration also focused on optimization, making NEO's AI models run efficiently on the robot's onboard computing hardware. This optimization is crucial for responsive operation, as robots need to process sensory information and make decisions in milliseconds to interact naturally with dynamic environments. Broader technology ecosystem. Beyond NVIDIA, 1X has developed relationships with other technology partners. According to Børnich, while 1X has partnerships with companies like OpenAI, they train their core AI technology in-house, occasionally co-training models with partners to enhance capabilities. These partnerships extend to hardware components as well. The sensors that provide NEO's vision, hearing, and touch capabilities come from specialized suppliers with expertise in those particular technologies. Battery technology, critical for a mobile robot, comes from partnerships with energy storage companies developing high-density power solutions suitable for robotics applications. 1X has also established relationships with academic institutions, collaborating with robotics research labs at leading universities. These academic partnerships help the company stay at the cutting edge of robotics research while providing valuable real-world testing opportunities for new algorithms and approaches. Open platform aspirations. Looking forward, 1X has expressed interest in creating more open interfaces for NEO, potentially allowing third-party developers to create applications and capabilities for the robot. This approach, similar to smartphone app ecosystems, could dramatically expand NEO's functionality by leveraging the creativity of a broader developer community. "We don't want to build every capability NEO might need," Børnich explained in a recent interview. "We want to create the platform and core capabilities, then enable a community of developers to extend those capabilities in ways we might not even imagine." This platform approach could potentially accelerate NEO's evolution from a specific task robot to a general-purpose assistant capable of integrating with smart home systems, custom applications, and specialized tools for different household needs. The future of NEO Gamma. Entering homes in 2025. According to CEO Bernt Børnich, NEO Gamma is going into a few hundred to a few thousand homes by the end of 2025. The company has created an early adopter program specifically designed to collect data on how these robots operate in real home environments and gather feedback from users with diverse needs and living situations. These initial deployments will focus on households in several geographic regions, ensuring exposure to different home layouts, cultural practices, and language environments. Early adopters will receive NEO robots at subsidized costs in exchange for participating in the data collection program and providing regular feedback about their experiences. This approach is revolutionary in the robotics industry. Instead of perfecting the robot in a lab and then releasing it, 1X believes robots need to live and learn among us to truly understand the nuances of human life. How else will they learn to open a door for an elderly person, move carefully around pets, or adapt to the unpredictability of everyday life? The final 20% of capabilities needed for a home robot can only be learned in actual homes, Børnich explained during the TED Talk. You can't simulate the beautiful chaos of human living environments, you have to experience them. This philosophy distinguishes 1X from competitors who prioritize perfecting capabilities in laboratory settings before deployment. Data collection and learning. The data collected from these home deployments will create a valuable dataset that 1X can use to train their AI models and continually upgrade NeoGamma's capabilities. Each robot will learn from its specific environment, but the insights gained can be aggregated, with appropriate privacy protections, to improve the entire fleet's capabilities. This approach creates a virtuous cycle. As more robots enter more homes, they encounter more situations and edge cases, generating more learning opportunities. This expanded dataset then improves the AI models, making future robots more capable, which encourages more adoption, and so on. The specific data being collected includes visual information about home environments, speech samples for improving language understanding, and movement data for refining motor skills. 1X emphasizes that all data collection follows strict privacy protocols, with users having control over what information is shared and how it's used. This real-world training approach could give 1X a significant advantage in the race to develop truly helpful home robots. While competitors might have more advanced laboratory demonstrations, Neo's experience in actual homes provides practical knowledge that's difficult to simulate. Privacy and challenges. Of course, this raises some serious privacy questions. Having a robot with cameras and microphones in your home is no small matter. According to 1X, customers will have control over when company employees can view NeoGamma's surroundings, whether for auditing or teleoperation purposes. The company has implemented several privacy safeguards. Users can designate privacy zones where Neo will not record data or will automatically blur certain areas in captured images. They can also schedule times when no data collection occurs. For teleoperation scenarios, users receive notifications when a remote operator connects to their robot and can approve or deny access. Despite these precautions, privacy advocates have raised concerns about the potential for data breaches or unauthorized access to the intimate details of people's homes. 1X has responded by emphasizing their security measures, including end-to-end encryption for all data transmission and strict access controls for employees who might view robot data. The home testing program isn't without technical challenges either. During a recent demonstration, NeoGamma showed occasional instability. At one point during an event, the robot reportedly started shaking and collapsed, requiring human assistance. Company representatives blamed technical issues like spotty Wi-Fi and low battery, which raises questions about the robot's reliability in typical home environments with imperfect connectivity and varying power conditions. Other challenges include adapting to the incredible diversity of home environments. Homes vary dramatically in layout, lighting conditions, furniture arrangements, and cultural practices. Teaching Neo to navigate this diversity represents an enormous technical challenge that the early adopter program aims to address. The competitive landscape. 1X isn't alone in this race. The humanoid robot space has exploded recently with serious competitors vying to be first to market with capable home robots. Figure, a Bay Area-based company with an active social media presence, has also announced home tests of their humanoid robots in 2025. They've generated massive buzz, reportedly in talks for significant funding at an impressive valuation. Figure's approach differs somewhat from 1XS, with a greater emphasis on autonomous capabilities from the start rather than the teleoperation bridge strategy. And then there's OpenAI, which is both an investor in 1X and reportedly exploring building its own humanoid robots. With their expertise in artificial intelligence, particularly large language models and multimodal systems, they could be a formidable competitor if they decide to enter the hardware space directly. Their investment in 1X might indicate a strategic interest in the hardware side of embodied AI without committing to manufacturing robots themselves. Other players include Tesla with their Optimus robot, which leveraged the company's experience in computer vision and manufacturing at scale. Boston Dynamics continues development on Atlas, focusing more on mobility and dynamism than on home applications. Agility Robotics with their Digit robot targets commercial applications like warehouse work but could potentially adapt their technology for home use. Each competitor brings different strengths, Tesla has manufacturing expertise and vast resources. Boston Dynamics leads in mobility and physical capabilities. Agility Robotics offers proven reliability in commercial settings. Figure brings strong AI talent and significant funding, and OpenAI provides cutting-edge AI capabilities. What sets 1X apart is their focus on getting robots into homes now, even if they are not fully autonomous yet. This incremental approach might give them a crucial data advantage as they collect real-world interaction data that other companies simply don't have access to. The question remains whether this early data advantage will translate into market leadership as the technology matures. The broader vision: transforming labor beyond household chores. Throughout the TED Talk, Børnich emphasized that NEO represents more than just a technological achievement. It embodies a vision for transforming how we approach work and household tasks. By creating robots capable of handling routine chores, 1X Technologies aims to make labor as effortlessly accessible as energy is today. This concept draws a parallel between historical technological revolutions, such as the mastery of electricity, and the potential for robots to similarly transform human labor. Just as flipping a light switch gives us immediate access to energy, Børnich envisions a future where accessing labor power could be equally effortless through robots like NEO. When electricity was first harnessed, it transformed from a scientific curiosity to the foundation of modern society, Børnich noted during his presentation. We believe robotics is at a similar inflection point today, transitioning from specialized industrial applications to a general-purpose technology that will reshape how we live. While much of the demonstration focused on household applications, Børnich's vision extends far beyond domestic settings. He described a future where robots like NEO could assist with complex industrial tasks, including building other robots, constructing critical infrastructure like data centers, and conducting sophisticated scientific experiments. This broader vision sees humanoid robots as general-purpose labor platforms that can be deployed wherever human-like physical capabilities are needed. Unlike specialized machines that perform specific tasks, a humanoid form factor allows adaptation to the wide variety of environments and tools already designed for human use, from door handles to kitchen utensils to scientific equipment. Economic and social implications. The widespread adoption of capable humanoid robots could have profound economic implications. Børnich suggests that robots like NEO could help address labor shortages in critical sectors, from manufacturing to healthcare. As populations age in many developed countries, there simply aren't enough human workers to provide needed services, a gap that robots could potentially fill. We're not talking about replacing existing jobs, Børnich clarified. We're talking about filling jobs that already go unfilled, providing services that are currently inaccessible to many people due to cost or availability constraints. This distinction is important for understanding the economic vision behind NEO, creating new capabilities rather than simply automating existing ones. The social implications are equally significant. By handling routine tasks, robots like NEO could free human time and attention for activities that machines can't replicate: creative work, emotional connection, and intellectual exploration. This shift could potentially transform daily life, particularly for people currently overwhelmed by household management, childcare, or elder care responsibilities. Addressing societal challenges. This broader application of humanoid robots could help address significant societal challenges, including labor shortages and the growing need for care in aging populations. Børnich believes that robots can contribute to answering some of the remaining big unanswered questions about the universe and our role here, positioning them as collaborative partners in advancing human knowledge and capabilities. The care crisis represents one of the most pressing applications. As populations age worldwide, the demand for caregiving services is rapidly outpacing the available workforce. Robots like NEO could potentially assist older adults with daily tasks, medication management, and even social interaction, helping them maintain independence longer and reducing the burden on human caregivers. Another critical application is accessibility. For people with disabilities or mobility limitations, robots could provide assistance that makes independent living more feasible. From fetching items to helping with personal care tasks, a robot assistant could dramatically improve quality of life for people who currently rely heavily on human caregivers or family members. The vision goes beyond simple household chores. 1X describes their mission as building a world where we do more of what we love, while our humanoid companions handle the rest. This isn't just about having a robot vacuum your floor, it's about fundamentally changing how we spend our time and energy. Imagine coming home to find your laundry folded, dinner prepared, and your elderly parent or child having enjoyed meaningful companionship throughout the day. This could transform elder care, childcare, and the work-life balance for millions. Ethical considerations. The path toward this vision is not without ethical complexities. As robots become more integrated into intimate home settings, questions arise about appropriate boundaries, dependencies, and the nature of human-robot relationships. 1X acknowledges these challenges and is actively engaging with ethicists, sociologists, and psychologists to understand the implications of their technology. One concern involves potential dependency. Could people become overly reliant on robotic assistance, potentially atrophying skills or reducing human connections? Another consideration is the digital divide. Will robotic assistance be available only to wealthy households, potentially widening existing inequalities? Børnich addresses these concerns by emphasizing that 1X's long-term goal is to make robotic assistance widely accessible, not a luxury item. Like any technology, robotics will initially be expensive, he acknowledged. But our focus is on creating systems that can scale to mass production, bringing costs down to the point where Neo or robots like it could be as common as household appliances today. Conclusion: a new era of human-robot collaboration. The story of Neo Gamma isn't just about a cool robot. It's about a fundamental shift in how we think about technology and its role in our lives. For decades, we've been creating digital assistants that exist in our phones and speakers. Now, we're on the verge of creating physical assistants that can move through and interact with the real world. This transition feels momentous, perhaps even more significant than the smartphone revolution. Just as smartphones put the internet in our pockets, humanoid robots could put physical assistants in our homes. Neo Gamma's appearance at TED 2025 represents more than just a technological demonstration. It signals a potential paradigm shift in how humans and robots might collaborate in the future. By showcasing a robot capable of performing household tasks with impressive dexterity and adaptability, Bernt Børnich and 1X Technologies have presented a compelling vision for robots as partners in daily life. The development of Neo Gamma, with its focus on safety, adaptability, and real-world learning, addresses many of the historical challenges in bringing robots into human environments. As Børnich emphasized in his presentation, the goal of this technology isn't merely to reduce household labor but to create a future where humans can focus on what truly matters to them. Are we ready for this? The privacy implications, social dynamics, and economic impacts are profound. But ready or not, Neo Gamma and robots like it are coming, and they'll likely change our world in ways we can't fully predict. In this vision, robots like Neo become tools for human flourishing, freeing time and energy for more meaningful pursuits while handling the routine tasks that consume so much of our daily lives. Of course, we're still years away from fully autonomous humanoid robots that you can just buy off the shelf. The current teleoperator approach is clearly a stepping stone. But the rapid pace of development is staggering. Just 10 years ago, 1X was merely a concept in Børnich's mind. Today, they are preparing to put humanoid robots in thousands of homes. What might the next 10 years bring? The future of human-robot collaboration is not just approaching, it's already beginning with Neo Gamma.